Hey everybody, this is Andy, and today we're going to be talking about the moon's revolution around the Earth and a couple of the phenomena that are associated with it. We're going to start off talking about the phases of the moon, and real quick introduction, the phases of the moon are the different shapes that the moon appears as to an observer on Earth over the course of the month. Now, to understand why we see different phases of the moon over the course of 29 days, the first thing that you need to understand is that planets and moons in our solar system, all celestial objects that are spheres, they are half illuminated by the sun, and that's going to be the half that's facing the sun, and the side opposite that is not going to be illuminated by the sun. So on Earth, we experience day and night because of that. So if I was an observer standing here, when I'm on the darkened half of the Earth, I'm experiencing nighttime. When the Earth rotates on its axis and the observer moves into that lit portion, they're going to experience daytime. And as the Earth continues to rotate and the observer moves into the darkened half of Earth, they'll experience nighttime. Now, since we're not standing on the moon, the fact that it's half illuminated by the sun is going to affect the shape that we see at night. So if the moon is here in this position, and I'm an observer here on Earth, since half of the moon is lit and that half is facing the observer here on Earth, then we would look up and we would see what we call a full moon, meaning that 100% of the illuminated side of the moon is visible to an observer on Earth over the course of the night. So as this person moves around the Earth, they can look up at any time and they can see this full moon in the sky. Now, over the course of the month, as the moon continues its revolution, now part of this darkened half is going to kind of enter the observer's view, and part of that illuminated half is going to leave the observer's view. And we can use this circle showing the moon's revolution, the path of its revolution, almost as a guide to show us what can this person see and what can they not see. So as the moon revolves, more of this darkened half of the moon is going to come into view, and more of that illuminated half is going to go behind the moon, and the observer will not be able to see it. So we have a change in phase, and each one of these phases has a different name based on the shape and based on what's happening to the shape of the moon. So let's start here, even though there is really no start or end because it's in a cycle. So these phases always happen in the same order, and it happens in a predictable way. But a lot of times people will start here with the new moon phase as kind of like the start of the phases. Now, I tell my students that a new moon phase is almost like saying no moon. So if an observer were to look up in the sky and be looking for the moon, they would not see any moon. And you'll notice too that the moon is technically visible during the day in this situation because the observer here would be able to look up in the sky and see where the moon is. Only they wouldn't be able to see this new moon phase unless the moon was directly in front of the sun and causing a solar eclipse to happen. But that only happens in the really specific instance when the moon is directly blocking the sunlight to an observer at that particular spot on Earth. So solar eclipses are pretty rare, and we'll see that dark moon with the sun behind it. One happened last year. So as the moon continues its revolution, more of this illuminated half is going to come into view for the observer on Earth. Let's slow this down a little bit. And after the new moon, the next phase that we have is called the waxing crescent. It's called the crescent because of the shape. So we have this crescent shape, and we call it waxing because from this night and moving forward, the shape of the illuminated side of the moon is going to grow larger until we get to a full moon. So here's the waxing crescent phase. You'll also notice that during this phase, the observer can look up and see the moon during the daytime. So it is another misconception that people say that the sun comes out during the day and the moon comes out during the night. That's actually not the case. It all depends on where the moon is in its revolution, and there are some times when a person can look up during the daytime and they can see the moon. And one of those times is when there's a waxing crescent. So days will go by, the Earth will rotate. When the moon is at about a quarter of the way through its revolution, we have the phase called the first quarter. Now you can remember that name by saying it's a 1/4 of the way through its full revolution. Another way to think of this phase is that since half of the moon is illuminated by the sun, and you can see half of that half, you're actually looking at a quarter of the moon in this position during that first quarter. The next phase up is going to be the waxing gibbous. Waxing meaning that the illuminated portion is growing bigger. Gibbous is that shape in between the quarter and the full moon, the entire portion. And then 2 weeks after the new moon, we have a full moon. That's when 100% of the moon is illuminated. We can see the entire lit half of the moon. And after the full moon, then that visible portion is going to start growing smaller. So we still have that gibbous shape again, but since it's growing smaller, we have the waning gibbous. Once we're 3/4 of the way through the moon's revolution, we have the third quarter or last quarter. When we have less than quarter of the moon visible, we have the waning crescent. Crescent because of the shape, waning because it's growing smaller. And after a waning crescent, the cycle will conclude going back to new moon or no moon. And that will happen again and again. The moon is never going to go backwards, so we're always going to see these phases happen in the same cyclical order. And it's predictable because it happens approximately every 29 days. And on the regions, they even sometimes round it to either 28 to 4 weeks. So you can think of new moon about a week later is the first quarter, a week later is the full moon, a week later is the third quarter, then 4 weeks after we would have another new moon. Okay, let's use this simulator to take a look at one more thing. And in order to do that, we are going to put a landmark on the moon, just like that American flag that we put there. So right now, this landmark is going to kind of serve as a placeholder. And if we watch the moon revolve around the Earth, we're also going to pay attention to how long it takes that flag to rotate one time, to finish one rotation, just like this observer on Earth is spinning around really quickly. Now, right now, this flag is pointing to the left, and we're going to watch to see how long it takes for that moon to rotate as it revolves so that the point is pointing to the left again. The flag is pointing to the left. And it's not going to happen until the moon has completed one full revolution. So since the period of rotation, meaning the time it takes for the moon to rotate on its axis, since that period of rotation is the same exact time as the period of revolution, or the time it takes for the moon to complete one orbit around the Earth, the same side of the moon is always going to be facing us. So even though over the course of the month we see a different shape of the moon, we'll still see the same landmarks and the same landforms facing us here on Earth. The first time that we saw the backside of the moon was actually when the Apollo missions sent astronauts into space, and they took a spaceship to the opposite side of the moon. They were the first people to actually be able to see the backside of the moon. Well, hope you found this video helpful, and I'll see you next time. Bye.